Hello again. So in this video, what I want to talk about is related to the sampling that we were just talking about, but something called conditional sampling. And so let me explain what that is. So before, when we were generating all of our samples from the distributions, let's go see some of the examples. So here we get Esteves, so Portuguese-ish name. Scroll up a little bit, we get Xin as a Chinese sort of name. All these samples that we're generating, it's sort of like the model's just randomly picking which nationalities these samples should come from. But what if I really only want, say, Portuguese names, and I don't really want Chinese names, or anything but else besides Portuguese? The ability to get samples just from a particular class is called conditional sampling. And the reason it's called conditional sampling is because effectively what we're doing is we're sampling from the conditional distribution. That is the original distribution conditioned on which class we want to sample from. So there's a number of strategies for doing this. Again, some complex, some simple. The most simple, most naive one is if we only want Portuguese names, let's just keep sampling and reject everything that's not Portuguese. That's called rejection sampling. It turns out that in some cases that's really good, and in some cases that's really bad. And in this case, it's on the bad end of things, because it might be a long time before we generate a Portuguese name, for example. And one of the things that we want to be able to do is somehow force our model to generate a name that's, say, like a mixture of Portuguese and Chinese. And if we're just randomly sampling, it's very, very unlikely that we're going to randomly get a name that's both Portuguese and Chinese. And so we'll be sampling for a long time. So what we want to do is somehow give our model a push in certain directions towards certain nationalities. And that's what we're going to talk about in this video. So in this picture, this is a picture we've seen before about just the generative model. And this blue box up here, again, this blue tensor, out_next_chars, those are sort of these parameters for that categorical probability distribution. And again, this is a very high dimensional probability distribution because this tensor has a lot of parameters inside of it. And so one strategy for conditional sampling is, given this probability distribution, we could try to develop some really complicated algorithm. That's beyond the scope of this course, though. What we're going to do instead is something kind of like cheating. And so let me click on this image over here. So this image is exactly the same, except down here, notice there's this green box added in. So let me go to the previous image. In this previous image, it's only the line tensor that's the input into our recurrent neural network. But in this new image, which represents our new conditional sampler model, we added this green box down here. And inside of this green box, you can see it's labeled category_1hot. And what this box represents is a 1-hot encoding of our category. So instead of, so we still have this line tensor, and this line tensor is taking in a person's name, but we're also going to concatenate the particular category that we want onto this line tensor. And that will help give our model a push in the right direction. So let's see, if we look at this green tensor, its horizontal shape, its width is still the length of our line, and its vertical height is the number of class labels. And again, that part is due to the one-hot encoding of the classes. Our overall input tensor then, this black plus this gray box, that's going to have a height of the length of the vocabulary plus the number of class labels. It's also no longer going to be a one-hot encoded vector, because there will be, in any given one of these columns, there'll be a 1 in the top part and another 1 in the bottom part. So there'll be 2 1s in each input vector now. Everything else about the model will be exactly the same. This vector, or this tensor, will get passed into our recurrent neural network. It'll do all of its stuff, and then we can predict our probabilities up here. But again, now when we're doing that prediction, these probabilities depend not only on the previous character, but also on the class. So that's both good and bad. The good is that our characters, we can sort of influence them somehow based on what class we want. But the bad is that we can no longer do any predictions of the class. So if you look over here, this linear layer, this tensor right here, is where we're doing the class predictions. But now these class predictions would be dependent on the actual input class down here. And so these class predictions are all going to be just like 100% accurate, because they're just getting the true value in as input, and so it'll just be dependent on the true value. When we're actually trying to do class predictions in the real world, we would not have access to this true value to be able to provide the right input into this model. So that's the limitation of this conditional model, is that we can no longer do this linear part out here predicting the class labels. We can only predict the next characters. We can do that in a better way. We can predict next characters in a better way over here, but we can no longer predict class labels. Okay, that's it for this video. In the next video, we will talk about the actual code for doing this.